Do you need the Fossibot 2400 watt power station? Let's find out. Do you know one of the best features on the Fossibot power station that you won't find on typical power tool power stations that are powered off of power tool batteries? Pass-through charging. Let's find out what that is. Now, we've seen power stations before, and we've even reviewed several power stations here on Shop Tool Reviews. This is the Fossibot 2400 portable power station. Now, is this any different than others? Well, actually, there are a couple of features on this that we haven't seen before. So first, let's get an idea of the size of this. It's about 15 inches wide and just about 11 inches deep, and height is almost 13 inches tall. I really dislike when we have cords and hoses and cables that are part of a tool or part of a product and there's not a place for them. Well, if you look right here on top of this unit, there's a little lid, and inside that lid are the power cable, other cables to connect to like solar panels and things like that. But right there in that top compartment on this unit. So we love seeing that. Let me go ahead and pull the power cable out. Let's just take a look at actually what we do get. So we have these connectors here, pretty common amongst most of your well-known power stations. So this would connect to your solar panels, which you can connect up to 500 watts of input on solar panels. And this would connect to your 12-volt cigarette lighter or auxiliary adapter in your vehicle and be able to charge the power station from your 12-volt supply with this common connection, which is going to be right there. So that's going to handle your input from your solar panel and or your input from your auxiliary port or your cigarette lighter in your RV, in your car, in your truck, or what have you. So those two cables that come inside of there, as well as the typical power cable that's just going to plug into the other side right here. Now, this is powered by Lithium Iron Phosphate batteries or LiFePO4 batteries. So you're going to get a lot of chargers, typically between 3,000 and 3,500 charges out of this. So a long lifespan before you really start seeing them degrade. Now, it will output up to 2,400 watts, and it also contains 2,048 watt hours of output. Now, that's really, you're not going to get a full 2,000 watt hours of output out of the tank, if you will, or out of the batteries. You're typically going to get, especially if you're using the 120 volt or 110 volt outlets, typically you're going to see somewhere between 80 and 85% efficiency, because what this is doing is turning DC power, so like battery power, into AC power, like your extension cords, your plugins, things like that. So that process is not 100% efficiency. It's got to transform the DC into AC and then output it. So typically you're going to lose somewhere between 15 and 20% of efficiency in that process. So again, if you're running, let's say, a coffee pot that's 1,000 watts, you're not going to get a full 2 hours of use out of that on a 2,048 watt hour output. You may get hour and 45 minutes of use. But again, continuous use on a coffee pot, that'd be pretty extreme. That's just giving you an idea. Now, a refrigerator, you may get a full 24 hours of use out of a refrigerator, depending on what size the fridge is, depending on how efficient it is, depending on how much frozen foods you actually have in the fridge. So just keep that in mind. And remember that when you're going camping or RVing or something like that, or the power goes out in your home, keep your freezer full. So frozen foods are going to help your refrigerator run much more efficiently. Anyway, let's go ahead, since we got the size on this, let's go ahead and get a weight. These things aren't exactly light. So 47 pounds and 3 ounces. Now you see we have a large screen here. We have a couple of outputs here on the front, but let's go ahead and turn this on. We have a power button here. If I just press it, it's not going to come on. So if it were just kind of in a dim mode and I pressed it once, it would kind of power up the screen. Right now I have the unit off, so long press on this, probably 3 seconds, maybe 5. I'd say 3 to 5 seconds. It's going to turn on. Now we're at 100%, so we're already charged up. and it tells me that I have 99 hours of use. Well, that's basically because I have nothing plugged into it. So this will do its best to kind of give you an idea, if you have something plugged in, of how long the power draw that it's drawing will last with the battery. Right here on the front, we have two USB Type A output. They're QC 3.0s. And then we have actually 4 USB Type C. Now these are 20 watts each. And then this bottom one down here where there's 2 more USB Type Cs, this is actually a 100 watt output. So if you want to charge your phone fast or charge your laptop, you want to plug into this one. And then here's another 20 watter. And you can turn these on or off. So I can turn this panel right here on, and then I can turn it off as well. And you'll see when I turn this on, we'll get a little USB-A type light up right there. When that's on, when I turn it off, it's going to go off. Also, if we have any power draw coming out, it should stay on. Otherwise, this might automatically turn that panel off. These covers right here are going to be weather resistant if they're plugged in or pushed in. Right here, we get a light, and it can be just a light, you know, to provide some light at night. If you hit it again, it will actually go blinking. So like almost an SOS light, like a strobe light. But anyway, so you have 3 different cycles of a light that you may need, maybe on a roadside or just, you know, at camp or whatever, turn that on to get some sufficient light. Again, we just showed that this is going to be your plug-in for like your solar panels or auxiliary power for your cigarette lighter. Here's going to be output of 12 volts, and I believe both of these are output and input, but this is going to be your typical, maybe you want to power up a cooler. We'll throw a cooler on here using the auxiliary port here in just a moment. So those are going to be both 12 volt input output. Actually not on the solar panels. Those will be up to 500 watts with that. I think I already mentioned that. And then down here, we're going to have another 12 volt barrel plug right here. So 12 volts at 3 amps maximum. And again, we can turn this on and off as well. We get another little signal right there telling us that panel is on, and we can turn it off. Take a look here on the side, and you'll see here there's a little door that flips up. They recommend this actually to be up when you're using this. And what it is, it's a pair of fans here on this side. There's also one on the other side, and it draws air across this whole unit, keeping everything nice and cool. So we like to see that. We really haven't seen that feature on others. We've seen several you can actually screw on kind of a shield or a shroud or something like that, but like the fact they're kind of spring-loaded. You can push them down and keep them out of the way, or you can flip them up, again, to get that airflow circulation. And then this one here is going to be your power. So you can see here, pretty typical power plug. Just going to plug in right here. And then the same thing with your solar panels. Just going to plug right in here. Then again, this is where you can charge with up to 500 watts. So by the way, this is the only place you can charge with the solar panels. The ones up front are only for 12 volts. So that's only going to be your 12 volt auxiliary or cigarette lighter. And this port is actually going to be for your input of your solar panels, which again, you can push up to 500 watts. Now that we have this cord in here, actually let's use this a bit to deplete the battery because we're at 100%. So undo this. And by the way, this is also basically a trip breaker. So if something funky goes out with the power or going on with the power, either on input or output, this may pop out, and all you have to do is push it back in. It's kind of a self-reset. You can see we have nice integrated handles right here on the power station. Let's flip it around to the back side. Really nothing here on the back other than the label. And then flip it around here on the opposite side. Again, we get that same fan cover that kind of flips up out of the way. And then this is where our AC output is. So we have 6 different 110, 120 volt plugs here for plugging in any of your typical devices, coffee pot, blender, refrigerator, you name it, drill, table saw, whatever you're needing to power right there. And again, up to 2,400 watts of output. Now I'm going to throw up here a large 12 volt cooler that we've used for several years. And I'll plug the 12 volt plug in and plug it in here to the cigarette lighter adapter. It's not doing anything yet because I don't have this panel on. Go ahead and turn that panel on. We see the marking there telling us it's plugged in. I've now got power up here on the cooler, and now we're about to start drawing some wattage out. Yep, I feel the compressor coming on. So we're drawing, I don't know, 60 watts or so. That should climb a little bit as this compressor fires up and starts kind of balancing out, if you will. And by the way, the temperature in here is 86 degrees, so it is not cold. So it's going to probably run quite a while before it pulls down to temperature. So again, you see that climbing even higher. Probably settle in around 100 watts is probably where this will probably run. And you can see it right now between 60 and 80 watts. But again, I expect that to kind of ramp up a little bit and see it somewhere around 100. So really not a lot of output to power up these smaller, cooler fridges. And again, if this were already at temperature, it would probably pull, 60, 70 watts and then shut off and not pull anything, then come back on. And these things really do a great job of being very efficient. And you can see we'll get 26 hours of runtime out of this power station to power up this cooler here. And again, that's pulling this down to temp. Once it's down to temp, it will probably go even longer than that. It'll probably go several days running off this power station, as long as you're not in and out of this too much. Okay, we're going to go ahead and get the heavy hitter out. And this is probably pretty self-explanatory, but what this is going to enable us to do is actually be able to fire up these 500 watt halogen bulbs. They're 500 watts a piece. And so each time we flip a switch, we can call on a different pair of them, bringing on 1,000 or 500 watts, depending on whether we have two in each set, or if we just have one in each set. We have a couple where we just have one, or one's blown out, so we can bring on 500 more watts. So we're going to bring up, say, 2,400 watts and see, if the unit is actually able to power that, or if it has trouble doing so. We'll also look at the readout, and we'll also take some measurements on the actual amp draw that we're actually getting. So we'll go ahead and I'm going to plug in number 4, number 3, and number 2. You know what? We'll plug all 4 of them in. Should be plenty of draw to bring this thing to its knees. And then we'll go ahead and bring on the panel. So you can see now we have the AC outlets on. We can turn this one off. So now the only one we have on is over here. Now right now, even with that cooler running when we had it plugged in, the fans have still not kicked on. So literally the sound is 0. There is no sound coming out of this at all. And even with the fans on, very, very low noise. You can't even hardly hear it. But we have still yet to have the fans come on because obviously we're not really stressing this thing out yet. But we got everything plugged in. Let's go ahead and fire some of these up. Okay, these things get very bright, so I've got some eye protection on. Again, we're at 0 watts now. I'm just going to bring on this last one, which is only 500 watts because we only have a single bulb in there. As far as the wattage here, it's saying 373. Yeah, and it's saying 342 on my amp draw meter. So 334. And does it get hot? Well, you can see how hot that's getting right there. That's actually starting to bring sap out of the piece of wood that's sitting under it there. We do have an aluminum plate under it. Doesn't quite go all the way under that last bulb. Let's go ahead and bring this other one on, which has got 2 bulbs. And we're sitting at, just showed 880. Now it's settling in around 750. Get on this one. 662, 660. Yeah, 675, 670 is what it's showing. Obviously no problem drawing that. So let's go ahead and call on. Now that should be somewhere north of, yeah, so that's 1,350 watts. And by the way, one outlet, 120 volt outlet should be about 15 amps. Should be about 1,800 watts on a single outlet. So we're not quite pushing that yet. We're at 1,300. Let's go ahead and call on another one. And now this is saying 2,200 watts. So this one's showing right at 2,200 watts. And my amp meter on all these is showing a little over 2,000, but it's sustaining this, not a problem whatsoever. So again, still sticking around that 2180, 2200 watts. I'm going to go ahead, I'm going to call on another one. My amp meter showing 22.8 amps. Actually, I'm sorry, we're showing 22.8 amps. So that's the amp draw, 22.8. And showing 2406 on this one, and it's staying on there. So if you take the 22.8 amps that we show here, again, sticking around 22.8, 22.85, you multiply that times 120 volts, you're going to get 2,736 watts. So this showing 2,400 watts. And also, let's just say 22.8 times 110 volts. Let's say it's operating at 110, so 2,500 watts. So I'm showing somewhere between 2,500 and a little more than that on the amps and the volts based off of the amp draw. And this is showing 2,400. So it's definitely not a slouch. It's not, I'm not reading something less than what it's actually showing me. And you can see continuously running this minutes. And it's actually starting to burn the wood underneath that stainless or aluminum plate. We hear the fans coming on. I don't know if you can hear it. Very low kind of whine from fans, but they're coming on to cool down. So let's bring these down. Now I'm just going to do a little test here. I'm going to bring this up past its limits and see how long it's actually going to run before it actually trips the reset breaker on here. And then I'm going to see how big of a pain it is to be able to reset this after it turns off and be able to use it again. Yeah, so it didn't take long at all, about 5 seconds to really throw a lot of draw at it to actually shut this unit down. Let me kill these. I'm going to kill all of them but one. And you see it's flashing this right here. It's not the reset button over here. So let's see if we can just power that down. And then I'm assuming when I power this back on, yep, so that's all you have to do. Basically push the button over there for the AC panel. It's going to turn it off, push it again, turn it back on, and then you're powered back up. So very easy when it does go into an overdraw to get that powering your units back up again. Okay, now let's show you a couple of things. So I'm going to lift the port over here. That's for our charging port. I'm going to plug in my charging cable. And you'll see right here we're down to 89% on our battery. I'm going to plug this in. And you'll see here now on the watts input, we're going to climb. It's still climbing. By the way, this will charge up to 1,100 watts input. But right now, it's only charging at 350 watts, and we're at 90% capacity. Now, there's a dial right here on the front. If I turn this, I can actually adjust the amount of wattage I want to charge at. So 1,100 watts is the top, 900, 700, 500, all the way down to 300 watts. Now, what that's helpful for is when you do have power and you're plugging it into something, you may have several other things on that circuit running, so you don't want to draw a full 1,100 watts of power. I actually did that the other day. I had it at 1,100, also had it plugged in with my air conditioner and with some lights, and it actually shut or actually tripped the breaker because I was trying to pull 1,100 watts here while still putting out over 1,000 watts on the other side as well, and it just over tripped it and tripped the breaker. And then I came back in and set this down to say 500 watts, and then I could still run the AC, run the lights, and still charge this. So I love it that it's right there. I don't have to, flip through a screen or a program or something like that. I can just right there with the dial be able to dial in the amount of input charging wattage that I want. And you can see that once it gets to say 90% or so, it will also throttle that down to actually charge the batteries more efficiently and to do it safely as well. If this were not at 90%, it was down to like 60%, you would see this actually, be at the full 500 watts or 900 watts or 1,100 watts or whatever you have decided right here with your dial. Now, also, we get pass-through charging with this, meaning and it can be used as a UPS or an uninterruptible power source, and it's pure sine wave as well, so it's safe for your laptops, your personal devices, stuff like that. So let's say you have your CPU or your main computer in your home plugged into this, the power's going in and out, and so you want to make sure that you have power and it's plugged in here. Well, while there's still power coming to the home, you may have it plugged in and it's doing the pass-through charging. In other words, we call that light on, and that light's on and the power's on. We're charging at, actually 688 watts because now we're pulling 500 watts here or 430 watts here. But let's say the power goes out in the home and boom, we're still powered up. So I have now unplugged the unit, and just a quick flicker of that, and it's fast enough of the switch over, it's not going to affect your electronics. Again, plug this back in, and we're back on electrical power. Again, let's look at that one more time. We'll unplug this, and you see just a shift in the brightness of that bulb, and that's about it. So many times when we review these, we get the questions of how long will it run this or how long will it run that? And really, when you're talking about refrigerators and tools and everything else, it really depends on what type of tool, what type of refrigerator, what type of compressor, what type of components are built into that. A good rule of thumb, again, is something heating like a heat plate or coffee pot, something like that, is typically going to be in that 1,000 watt range. Whereas a refrigerator is going to throttle a lot more. Again, may run at a few hundred watts initially while it's cooling, but if it's nice and cold already, which is, again, a big tip there, keep everything cold, then keeping that running is going to be a lot less because it's not going to run at 100 watts or 200 watts all the time. And it's really quick math to find out, how long will it last? Once you find out, and typically you can, a lot of times, look on the tool, look on the product, and it will tell you how many watts it actually draws. So we have 2,048 watt hours of output. In other words, this would put out 2,048 watts for 1 hour. Pretty easy, right? And for simplicity, let's just call it 2,000. Okay, so if we have 2,000 watt hours and we have something that draws 200 watts, well, all we have to do is quick division, okay? So 2,000 divided by 200, I hope you can do that math, and we'll do this real simple for you, and we'll just cut out two of these, cut out the zeros, and so it's 20 divided by 2, that's 10 hours of runtime from whatever's drawing that 200 watts. So it's not tough to do the math on these once you understand the watt hours are going to be your tank capacity or your fuel tank's size, if you will. And then your watts is going to be your output. How much can it actually do? This is going to be how long it can actually do it. So you can quickly do the math. If you had something that was 200 watts and 100 watts, and add that together and divide your 2,000 by 300, and that will give you how long it will actually run that. And another question is always, how many batteries can I charge with this? Since we're a tool channel, many times, and these things are very handy, whether it be, you're going to a job site and you don't have access to a generator or power cord, something like that. Makes it nice to have one of these, and maybe you can power several of your tool batteries or recharge them as you need it. Even in my case, we've got 5 acres and, maybe across the pasture, and know I'm going to be doing, some fencing, something like that. I don't want to keep coming back and charging batteries, so I can take something like this out there and know that I can get X amount of battery charges out of this. Now, how many times will it do it? Well, again, it depends on your battery. If you'll look on your battery, or 144 watt hours. So that tells you the size of the batteries, which is 18 volts, or 18 volts times the 8 amp hour battery. So 8 times 18, 8 times 10 is 80, and 8 times 8 is 64, and 80 plus 64 equals 144 watt hours. So now we know this is 144 watt hours, this battery, and we have, again, we're just going to, for the sake of, 2,000 watt hours of the battery. So then we'll take 2,000 divided by 144 equals, so that means we would fully charge almost 14 batteries. So 14 of these 8 amp hour, 18 volt batteries is how many batteries we could charge off of this. Now that's not really true because we really need to take our 2,000 watts and do that times 80%. And so right off the bat, we're going to be probably dealing with somewhere around 1,600 or 1,750, something like that, of watt hours. But again, you can quickly do your math to find out how much it's going to charge. The Fossibot 2400 did everything they claim it to do. It outputted at least 2,400 watts, in fact, over that, and did it for a substantial amount of time, like, 10 plus minutes or so of powering all these lights at 2,400 watts plus, or right around that 2,400 watt mark. Now, when I pushed it way over that, yes, it immediately just kind of shut down, which is supposed to that's supposed to be exactly what it does, or that's exactly what it's supposed to do. That's a little better verbiage there. For resetting that was very easy. Just push the AC outlet button and it turns it off, and then you turn it back on and you were good. So that's all you had to do to turn that back on. This thing is super quiet. In fact, it's absolutely quiet until the fans come on, and then it's still just kind of a small hum, a small whine from your typical electronics fans. It's not a high pitch, real high pitch scream that kind of hurts your ears, but you can just tell that it's running. If you're close to it, you're a few steps away, you're not even going to notice it. If you were sleeping at night, would you hear it? Well, maybe if it's right by your ear, but otherwise it's just going to have that electronic hum that you're not going to notice. We do like the fan doors that kind of pop up and spring up and provide some shielding, as well as allow airflow, cross ventilation across this. Again, the LiFePO4 batteries is going to give you 3,500 charges as far as a life cycle goes. So this thing should last you for several years. And pricing on this is going to be, right now I'm seeing like $699. So about $700. You can find this on Amazon. We'll have a link in the description if you're interested. So if you're needing one of these, be sure to check this one out. Also keep track of us on Instagram, Facebook, Twitter, and even TikTok. And if you don't mind, hit that like and subscribe button if you haven't done so already. And by all means, if you hated our video, well, give us a thumbs down. But let us know in the comments why. Have a great day and keep smiling.